Morning again. So, welcome back to Coding on Swiboe, the next generation text editor. And yesterday I rather left you very quickly and unceremoniously because my computer started overheating. And if it starts overheating, it gets mighty slow and then we cannot work anymore. So today I made some changes. So with some luck, that won't happen anymore. Today it's also not that super hot in Germany, so maybe we'll all be fine. So what have we been working on? We were actually looking into our configuration file, and we wanted to actually change how the function is executed that is executed when you press a certain key. So in this case, we wanted to have this mapping that maps to, if you press the up button, to actually call this function, and that was already working, but now we wanted to change this function to actually get passed through a client, an RPC client, so that we can make this RPC call here. And yeah, unfortunately, we are not quite there yet. So basically, we were working on getting this client into Lua, right? We already have a Rust class that implements that client, and now we have to get that to Lua. And we started out with this. Basically, we created a new meta table that is called thin client. I read up on that a little bit, and it should be more namespaced like that. So we call it Swiboe thin client for now. And then I started here like pushing a string to a function and push a function next. But actually, I learned that there's a way to do that quicker, and there's actually a wrapping in the Lua abstraction that we're using here, which is called set functions, and it will just take a reference to a slice of function names and functions, and will set all those functions into the table that we have. So basically, all we can do is here we just basically we copy this here and make a new table, and we call that thin client functions, fns maybe, and that is indeed a slice. Or it's an array of length 1 of static strings and Lua functions. So basically like that. And there will be some function, and here that will be Lua some function, right? Great. And then down here we actually have the new meta table, and now we can simply call this state set fns, where is it? Which takes the state and the functions and the length. So basically like so. And that should be thin client functions, and there's only one of them. Cool. So basically that should be all that is needed. We created a meta table and we set the functions to it. And I guess that's it. So what remains to be implemented though is then this push thin client here. And I'm not quite sure how that looks actually. So, hmm. We have to push the user data somehow. I'm looking at the documentation here of Lua right now to figure out how that works. And unfortunately, the documentation is for C, and I mean we use an abstraction over C, the Rust abstraction, and there everything might be different again. So let's see how that actually works here. So we need something like new user data. Maps to Lua new user data. That sounds really great. The pointer returned is owned by the Lua state, and it will be garbage collected when it no longer is in use or the state is closed. And we have to implement a garbage collection meta method to actually not leak that memory. That makes sense to me. And what does it take? It actually takes the size of our type. Oh, look that, wow. Unstable, reason this is an experimental function, but that's exactly what we want, right? We actually want, we have a struct. Yeah, we give it a struct, and it returns us a raw pointer to that struct that we then can use to populate that. So actually that looks very much like what we want. So let's try that. Let's copy that out, and basically here we would like to have Lua state. Does it actually have an example on how to use it? Yeah, here. Lua set meta table from registry. I think that's actually precisely what we want, right? Doesn't it? Seems to be too good to be true, but we'll see. So basically we have a... we already have a thin client though. Yeah, we get past... Actually we cannot only take... we actually have to take ownership of this thin client, or do we? Oh, that's actually pretty hard, right? So the problem is we have a thin client, right? We cloned it here when we prepare our function call. And we own this thin client. But when we actually pass it to Lua, Lua takes ownership of that one. So we have two options now. We either can say, well, we give Lua a thin client each time we call push thin client, so it gets a new clone that it can do with whatever. Or alternatively, we can say, oh, no, there's only one thin client for this particular function call, and we only pass a reference to Lua, and that will be our user data. And actually, I'm not quite sure what the best solution is here. Probably for now, we just clone that. That is like the simplest thing. But let's leave a note here. Should we instead just pass a reference to Lua? I don't know. I really don't know. So we still have the, like, that doesn't actually help us anything though. So we basically, what we need is, we need something very similar to this one, but we already have an object, right? We actually want to transmute that into that. Whoa, people, that gets now really unsafe. Really unsafe. So Lua state, we would like to get a pointer, please. That is the size of a client thin client, right? And we would like to get that back as a mutable pointer. I think that's fine. New thin client is this one, and that is now owned by Lua. And now what we would like to do is actually mem copy. Does that exist? Does that exist? Let's look in the Rust nightly docs. Mem copy. There must be something like that, right? Transmute copy. Transmute copy, I guess, is what we want. Maybe we can still use this one here. Basically saying, mem transmute copy thin client. Like so. And basically this transfers the ownership to Lua, and of course that's like so unsafe. This transfers the ownership to Lua, and now we actually have to mem forget the client we had. Basically we best do that here. So that Lua is not Lua, that Rust is not actually deleting our thin client. That would be terrible in this context. And And then we actually just need to set the meta table from registry, right? And that should be it. But this, of course, here leaks memory. This leaks memory. We have to provide a garbage collection method for the Lua object. And you know, people, I think that's nearly it. One thing that we need to change is that actually this push thin client pushed an argument, and here up in the p call we actually say that we don't have any arguments. So we actually, the prepare call needs a num arguments here, which is a integer, and at the beginning where this is actually created, which is here, num arguments is actually 0, and here just before returning, that is actually done here, just before returning we increment that by 1, and this p call here that will actually, I think it is first number of arguments and the number of return values, so it will be self number of arguments that we pass in here, and here we miss a comma, and here we miss a semicolon, and now, and this must not be my struct, that actually needs to be how do I call it? Swiboe thin client, maybe? Yes, yes, yes. And I think that should be it. Of course, that will be pretty hard to get it actually to compile, but no. Basically, if we remove all of this here and say, instead of this, we actually would like to call client some function, that should work. That should work. And actually don't use up, because up is already mapped in Rust, or maybe not, I'm not quite sure. Well, we'll see. Let's build. Like, actually, I'll build that, build the terminal GUI. Oh, I was already in the terminal GUI. So, let's build that. That's remarkably little compile errors so far. Oh, we're still compiling Swiboe though. We didn't, there we go. There we go. That's precisely what I was expecting. So, use of undeclared type or module client. Interesting. So let's start there. It doesn't like client. Why doesn't it like client? Because we didn't import it. Use Swiboe client. I think that's it. And use of undeclared type name size t. I think that's from the libc crate. Yes. So we already imported that, but we have to explicitly use that here. So there was this error here. Use of undeclared type name t. Of course, we have to actually, this is not t here, this is, yeah, what is that? Is that actually a mutable pointer to a thin client? I guess it is. Could be. What else? Unresolved name state. True. That is called Lua state. And we have awfully many empty lines in this function. Okay, and mismatch types. It would like to have I32, and I gave it an I size. So probably this needs to be a Lua integer instead. Nope. Okay. Then we make it an I32 and everybody's happy. Nice, nice. So config file runner, oh yeah, I remember we changed config file runner to take something. Probably a client or a thin client. Oh, it takes a thin client. And where do we actually create that? In 122. What is that function? I don't think this function is used anymore. This function takes one parameter, but two parameters were supplied. Okay. Set meta table from registry. What does you what is it? What are you doing? It just calls Lua set meta table, and that doesn't take a reference to anything. So let's look up in the docs. Lua set meta table. What does that do? Pops the table from the stack and sets it as the new meta table for the value at the given acceptable index. So it just takes an index here. That's really weird. Apparently they changed that in Lua 5.3 or 5.2. Set meta table. Here, found it in the Lua 3 docs, and sets the meta table of the object at the top of the stack as the meta table associated with the name tname in the registry. So at the top of the stack. So basically this -1 here is actually not really needed, right? And that should be it. Unable to infer enough type information about underscore. Type annotations are required. Actually, we never ever use this new, or maybe. Actually, we do that twice here. That can't be right. Something here is really wrong. Let's try. I don't know. So basically that would be a mutable pointer to a, that is a mutable pointer to a client thin client, I would say. And that is a empty chunk of data that we get returned by this. So basically I would expect this to work. All right, let's start here. First step. Not all return path return value, that's a different error. So that seems to be working here. And basically we have an empty chunk of memory and we would like to transfer the data from this thin client into this one. It would be nice if there were like a Rust move, mem move or something, because that's precisely what we want. We would like to drop the old value while moving its data into the new one, but that doesn't seem to exist. Drop, forget, replace. Replaces the value at the mutable location with a new one, returning the old value without deinitializing or copying either one. Swaps the value at two mutable locations of the same type without deinitializing. Transmute, I guess it is transmute copy, but that's not quite working. Guys, I really don't know how that works. Basically, this thin client, that will be an uninitialized piece of memory to user data typed. I don't know. I don't know. I guess this transmit copy is still our best bet here. Basically doing this. Seems like it likes that. Okay, let's continue on. Not all control paths return a value 63. That is true. That should return 0. Cannot move out of borrowed content. Wow. Yeah, that's fine. That is actually a mutable reference, right? That's just to save some typing. And now it says cannot move out of borrowed content. Oh, cannot move out of borrowed content because... Really? Do I have to introduce a scope here for that? Like so? Now you like it? Apparently. This function takes 1 parameter but 0 where supplied. Yes, that is now in the terminal GUI where we actually expected to create a config file runner here, and we actually need a client for that. So instead of running a config file first and then creating the client, we create the client now before that, and this actually takes a client clone. Right, that will return a thin client, and that should just work. So exciting, exciting. What happens now? If I run, that's for the server, that is for the client. And what should happen? If I press the up button now, this function should be called. So basically, let's make sure that inside the Lua function, still inside the Lua function. And here in between, we actually call out to the client. Unprotected error and call to Lua API, attempt to index a nil value. Wow, that doesn't sound great. That must be where we actually create the config file runner, right? What do we do here? We call state new meta table. Is that not actually pushing the meta table? That's the only explanation that I have for that. Lua L new meta table, I think. What do you do? If the registry already has the key tname, returns 0. Otherwise, creates a new table to be used as a meta table for user data. Adds to this new table the pair, whatever, and adds to the registry the pair and returns 1. In both cases, pushes onto the stack the final value associated with tname in the registry. So that should work. That should work. We set a new meta table, and then we set the functions in that. And it could be that we actually have to pop this function, maybe. Set fns. What are you doing? It calls Lua L set funcs, and what does that do? There we go. Registers all the functions in the array L. in the array L. Into the table on the top of the stack. When nup is not 0, all functions are created sharing nup up values. Oh, that's wrong. That's wrong. That's wrong. We don't have any up values. Please, no up values here. Compile, compile, compile. How are we doing on time? Oh, nearly 30 minutes already. Time flies when you're having fun. Okay, so it started up. So far, so good. And if I now press the up button, what happens? Nothing. Nothing. That's remarkably unremarkable. Well, I don't trust the up button. Let's use something that is like simpler. A, for example. Still nothing. Nothing. Nothing's happening. Interestingly enough, I is also not working anymore. We broke it. Guys, we broke it. We broke it. It seems like this actually broke it. So let's remove this and try again. Of course, now like our config.lua will not work, so like this will not work, but the I should still work. Let me just double check if Lua pcall is actually taking the parameters in the order I expected. Yeah, it takes the number of arguments first and then the results later. So now I works again. Great. So actually this call here, push thin client, breaks something. What does it break? What do? We make a Lua state. We push a new user data. New thin client. Yes, we. What actually? Do actually both of these calls not need to be unsafe? I'm not sure. I maybe not. Maybe this one I don't think, but this for sure. And then we set the meta table from registry, and then let us just make sure. So we have the get top function, which will give us an information about here. So echo Lua state get top. That will give us an information on how many values are on the stack here and down here, right? And basically what we expect is that there is one more element on the top of the stack at the end of the function than there is at the beginning of the function. Did I actually bring back this? Did I bring uncomment again to push the client? Push thin client. Yes, I did. Okay, so if I now press I, it will actually say, wow, that's wrong. That's wrong, right? It says here we have 2 and then we have 4. Now we have 4 and then we have 6 and then we have 6 and then there are 8. There's too many. Too many. Too much stuff on my stack. Why are there so many? I mean, what? Set meta table from registry? So like here I expect this. Oh, still do it twice. I still do it twice. That was not clever. So there should only be one now. There should only be one now. Why does compiling take so long? Am I actually compiling in release mode? Probably. Probably that's that. Okay, that looks better. And now it says inside the Lua function. Wow. So we got a little bit further. We actually, like, we see this printing, but we don't see this call and we don't see this call. So we only got till here, which is progress, I guess. Progress. So what does that actually mean? So if I remove that, so something actually arrives here. What happens if I print the client? Remove the release mode and build faster. An unknown error occurred. Interesting. So we seem to have some sort of panic. Let's run the binary directly. Core dumped. Core dumped. That's not good. That is absolutely not good. What happens if we don't actually touch the client? Does it still core dump? Yep, still core dumps. So what's wrong? What is wrong? What is wrong here? I mean, the only explanation I really have is that this is not working. This seems to be doing the wrong thing. Really sad. Really sad. I guess that must be it. Oh well, at least we made some progress, right? We pushed a function table, a meta table that is called. We successfully pushed that, and we populated it with functions. We also successfully create a new user data for Lua, and we actually associate it with like some data from our meta table here. But apparently, it is not enough to actually. It's not quite working. Apparently, there's still something wrong here. Let me run it real quick again without setting the meta table, and then we can see if this is actually, like, maybe that is what Lua is not liking. Nope, that's not it. Oh well. Okay, folks, I think that's all we do for today. We produced our nice, wonderful first core dump in Rust, which really shows you a language is only then safe if you are only dealing in the safe language, and if you start dealing with stuff like unsafe, and if you start dealing with stuff like Lua, which is inherently not safe, then you have crashes on your hand pretty quickly. But we'll figure that out. Okay, talk to you guys